Alright, this kind of exponential equation is going to be the kind where we're going to try and make the bases be the same. So when I take a look at this one, if I look at this side I have a base of 9, and on this side I have a base of 27. And the way that I kind of think about this when I decide whether I'm going to use logarithms or whether I'm going to try and make the bases the same is I think about the relationship between the bases. So when I look at 9 and when I look at 27, I definitely know that there's a relationship there with factors. I know 9 times 3 is 27. So immediately I'm thinking that there is something that could possibly be done here. So first, if I consider 27, I'm going to think, can I make that have a base of 9? And the answer is no, because if I do 9 squared I get to 81 and that's too big. So I'm going to go smaller. I'm going to think about that 9 times 3. And I'm going to see if I can make them have a base of 3, in which case I'd have to change both the 9 and the 27. So I know 9 is 3 squared, and if I think about it, 27 is actually 3 cubed, so this should work. What I'm going to do is I'm going to rewrite the 9 as 3 squared, and I'm going to rewrite the 27 as 3 cubed. And then I'm going to inspect this before I move on and make sure I haven't changed anything. So I'm going to look at this. 3 squared is the same thing as 9, and my exponent is still the same. 3 cubed is 27. That's equal. X plus 4 is still the exponent. So this is literally exactly the same equation here and here. I haven't undone anything. I didn't add. I didn't multiply. I have exactly the same equation. It's just my 9 and my 27 are fancy in this second step. From here, I'm going to use the power property of exponents to know that when I have a power on the inside and an exponent on the outside, I'm going to multiply those two together. And so I'm going to get 3 to the 4x plus 2 power equals 3 to the 3x plus 12 power. And now they have the same base. They have a 3 and a 3. And if the bases are the same, that means that the exponents have to be the same if I have this equal sign that tells me that the left-hand side is the same as the right-hand side. So at this point, the bases don't matter anymore, and I just have 4x plus 2 equals 3x plus 12. And I'm going to work on getting x by itself. So I'll subtract 3x from both sides. And I get plain old x plus 2 equals 12. Then when I subtract 2 from both sides, I get x equals 10 as my answer. Here's another one to try. I've got 16 and I've got 128. And I might not be quite certain about the relationship here, but again, I see bases on both sides, so I'm going to think about it. If I really don't know where to go from here and don't know some powers, I'm going to think about a couple things. I'm going to think, all right, 16 is 4 squared. So 4 squared equals 16. I might consider 4 as a base. I also know that 16 is 2 to the 4th power, so I also might consider 2 as a possible base. So I'm going to look at 128, and I'm going to divide it. Let's divide it by 4, since that's the bigger of the two numbers, and just see if 128 is in fact a power of 4. So when I divide this, I get 32. And when I look at that, I know that 4 is the power of 4, but 32 isn't a power of 4. It's just divisible by 4. So I'm going to start thinking about this base of 2 instead. And if I look at my numbers that I have here, 4 and 32 are both powers of 2 that I'm pretty familiar with. I know that 4 is 2 squared, and I know that 32 is 2 to the 5th. So if I think about 128 as 4 times 32, and there are lots of other ways to think about it, but I'm just thinking about it like this since we already did the work right here. This is really 2 squared times 2 to the 5th, which is going to give me 2 to the 7th power. So I'm going to rewrite the right-hand side as 2 to the 7th power. to the 2x plus 1. And on the left-hand side, I know 16 is really 2 to the 4th power. And that gives me, whoops, that's a minus. Let me get my eraser. So 4x minus 1 on the left-hand side. At this point, I'm going to distribute those exponents again. So I have 2 to the 16 minus 4, 16x minus 4 equals 2 to the 14x plus 7. At this point, my bases are the same, which means I can kind of forget about them. And I'm going to look at solving 16x minus 4 equals 14x plus 7. I'm going to subtract 14x from both sides. That's going to give me 2x on the left-hand side. And then if I add 4 to both sides, that's going to give me 11 on the right-hand side. And if I divide by 2, we're going to get x equals 5.5, or 11 over 2 as our final answer. Okay, last problem where we're going to make the bases the same. On this one, on the left-hand side, I have a base of 3. On the right-hand side, I have 81. So what I'm thinking in my head is 81 is really 3 to the 4th power. So I could solve this using logarithms, but if I can make the bases the same, that's going to be the easiest, fastest way, at least I think. So I'm going to have this on the left-hand side. I'm going to have 3 to the 4th power on the right-hand side. Again, at this point, when I have the bases the same, they're not going to matter for my solution. So I'm going to take the exponents and use those to solve. If I add 5 to both sides, we get 3x is greater than 9. When I divide by 3 on both sides, we find out that x is greater than 3.